Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and this short video, another video in our series of videos dealing with coordinate geometry of the line, is just going to talk about, I suppose, the concept of the slope of a line given 2 points on the line. Okay, so can we develop a little bit of a formula that allows us to calculate the slope of a line if we know 2 points on the line? Okay, that's really important for us. So let's try to rationalize what we're looking for here. Okay, so let's just create an x-axis, okay, or x-axis, and let's create an axis perpendicular to that. We're going to call the y-axis. Okay. Okay. And what we want to do is we want to consider a particular line. Okay, so let's say we have a line, and what we want to do is we want to calculate the slope of this particular line. This line is line L, let's say, for argument's sake. So what we'd like to be able to do is calculate the slope of this line, okay, given 2 points on the line. So let's choose our 2 points on the line. So let's say we choose the point A. Let's say we choose this point here is x1, y1, okay. And let's say we choose another point here, okay, which is the point B. Let's say which is the point x2, y2. Okay, so we have 2 points on the line. Okay, now what do we mean by the slope? I suppose we're not really proving a formula here. We're presenting a definition of what we really mean by the slope of a line. Okay, so the slope of the line is the angle that the line makes with the positive x direction, if that makes sense, or the positive x direction axis. So from here up to here, that this is the slope of the line. It's the gradient of the line, if I should say that. It's how steep the line is. Okay, but how do we measure that? Okay, how do we talk about steepness? How do we talk about gradients? Okay, so what we're going to do first of all is we're going to construct a right angle triangle here. We're going to take this point here, x1, y1, that's on the line L, and we're going to, let me actually use a different marker. No, I'll use the same marker, okay? And what we're going to do is we're going to continue this across in this direction here, parallel to the x-axis, okay? So it's parallel to the x-axis, which means that any point on this particular line, okay, any point is parallel to the x-axis, so any point on the line is going to be a distance of y1 above the x-axis. And similarly here, we're going to drop a perpendicular from x2, y2, down to here. So any point on this particular line is going to be this distance. It's going to be a distance of x2 away from this particular vertical axis, which is the y-axis. Okay. So what we really have, let me just continue these particular values down here, okay, down to here, and maybe down to here, okay. So this point here, when I drop the perpendicular from the point x1, y1, it cuts the x-axis at x1, okay. This vertical here, when I drop it down here, it's going to cut the x-axis at the point x2. Okay, because this point is a distance of x2 in the x direction. Okay, and similarly, when I bring this across here, when I produce the horizontal across to the y-axis here, this point is of height y2. So when I produce it across, this is going to be y2, and in a similar manner here, when I produce this point across to here, this is of height y1. So this is going to be y1. So what we have now is this distance here. This distance here between this point and where it intersects this horizontal, okay, is going to be y2 minus this bit of a distance. It's going to be y2 without this distance here, okay? So it's going to be y2, the whole y2, without this dotted piece. In other words, it's going to be y2 minus, well, this dotted piece represents y1, so it's y2 minus y1. And in a similar way, this particular distance here, okay, is going to be, well, it's this whole length here. It's the whole length of this line without this piece here. Okay, let me try to do that again. It's the whole length of this line here, okay, without this piece here. Okay, this piece here is of length x1, so it's the whole length of the line which is of x2 without this piece here which is of length x1. So this distance here is x2 minus x1. Okay, and we define the slope. The slope of a line, okay, we define the slope of a line, okay. It's symbolized by m, okay, to be the ratio, okay. It's going to be the ratio of this vertical change. This is our vertical change here, okay. So this thing here, okay, is our vertical change, okay. And this thing here, I suppose, this thing here is our horizontal change. Okay? And we define the slope of a line, it's going to be symbolized by m, to be the ratio of the vertical change of the ratio of the vertical change to the horizontal change. Okay. In other words, it's this ratio here. Okay. So it's the vertical change, okay, relative to the horizontal change. That's what we mean by the slope, and that's what m is. M is equal to that. But what is it? Well, m, this vertical change, is y2 minus y1. It's y2 minus y1, which needs to be divided by this horizontal change, which is x2 minus x1, which is exactly the formula that we require, that we've seen so many times, which is the slope of a line. Okay, so this formula now is the slope of a line L. Okay, given 2 points on the line, x1, y1 and x2, y2, we have this particular slope formula. Okay guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at National College of Ireland, and I hope that this video, another video in our series dealing with coordinate geometry of the line, and in particular the slope of a line given 2 points on the line, I hope that this was in some way intuitive, and more importantly, I hope that was helpful for you, and thanks for watching. Okay, bye bye.